mathgenie.
In this video, I'll be talking about the introduction to prime numbers. As you guys know, you guys probably have heard of prime and composite numbers back in middle school, or if you're currently in middle school and you haven't learned these yet, you'll probably learn this sooner or later. So even if you already know this, I do recommend you to watch this video for some recap. Or if you haven't learned it yet, be sure to use this as like an introduction to prime numbers. And in my next couple of videos, I'll be talking more about prime numbers and some different other quality of numbers that I think will be useful for math competitions. So let's go ahead and start with this introduction. All right, so what exactly is a prime number? Well, a prime number is a number that only has the factor of itself and 1. So how do you know if a number is a prime number? Well, for example, if you see, let me start with some easy examples. If you see number 3, well, how do you know if 3 is a prime number or not? Well, what are the factors of 3? Well, I can only think of 1 and 3, right? 1 and 3 is the only factor of 3 I can think of. Remember that, for example, I know that 1.5 times 2 gives you 3, but this is not a factor of 3 because factors only consist of whole numbers in this case. All right, so we can't do that. So since 3 only has 1 and 3 as its factor, we know that 3 is a prime number. But let me give you another example. Let's start looking at some more composite numbers. So for example, let's look at number 4. Well, we automatically can write down 1 and 4 as the factors. But is there more? Yes, we have 2. Because we know that 2 times 2 gives us 4. So in this case, since 4 has more factors other than itself and number 1, we can say that this number is a composite number. And now let me give you a tricky problem. What about 1? And let me tell you guys this comes out in math competitions. So I do highly recommend you to go ahead and memorize this. What is 1? Is 1 prime or is it a composite number? What do you guys think? Pause the video and see if you can get it right. Surprisingly, number 1 is neither prime nor composite. Number 1 is not prime and number 1 is not composite. What does that even mean? Well, remember that for a number to be a prime number, it must have at least 2 factors, 1 and itself. And for a number to be a composite number, the numbers must have more than 2 factors. Well, number 1 only has 1 factor, and that is 1. So it can't be prime because it doesn't have at least 2, and it can't be composite because it doesn't have more than 2 factors. So 1 is neither prime nor composite. This is very important because a lot of math competition people who make this test know that students do struggle with this concept. So they will put this, not like directly, they won't ask you, is 1 a prime number or not, but they will use this concept in their problems to trick you guys. So I do highly recommend you to go ahead and just know that 1 is neither prime nor composite. Alright, so let's look at some more examples about prime numbers. I'll give you some quick examples for us to solve. For example, is 181 prime? Okay. This is not a small number. Some of you guys may think this is a small number, but this, well, you can't actually find all the factors on the top of your head, right? So this is when we incorporate the divisibility rules that we learned in the previous videos. So if you guys don't remember, I will link the video links down below in the comments section, in the pinned comment section, so you can refer to the videos before actually solving this one. But in my previous video, I talked about divisibility rules for numbers 1 through 11. And in that video, I talked about how you can quickly know that a certain number is divisible by numbers between 1 and 11. So we're going to use that divisibility rule to solve this problem. Is 181 prime? Well, let's kind of switch back to the divisibility rules. Pause the video right now and see if you can figure out what numbers or what factors 181 has using the divisibility rules. Alright, let's see what the numbers are. Let's start with 2. Is 2 going to work in this case? Not really. So we can eliminate 2. What about 3? When you add up all the numbers, 1 plus 8 plus 1, do you get a number that is divisible by 3? Not quite, because when you add up all the numbers, 1 plus 8 plus 1, you get 10. And we know for sure that 10 is not divisible by 3. So therefore, we know that this number isn't divisible by 10, 3 either. Let's look at 4. Is the number formed by the last 2 digits divisible by 4? So is 81. Is that divisible by 4? No. So we can eliminate that. Let's look at 5. Is this number divisible by 5? Definitely not, because the number doesn't end in either 5 or 0. What about 6? Is the number divisible by 2 and 3? Nope, because we just eliminate that in the beginning right here. Let's look at 8. And remember, the 7 doesn't really have a divisibility rule. So remember that you actually have to divide for number 7. And when you divide, you can just eyeball this, but you can't divide 7 into 181. So we can eliminate that too. Let's get 8. The divisibility rule for number 8 said if the number formed by the last 3 digits, it's divisible by 8. Well, we know that the 3 digits that they're talking about in this case is 181. And we know that 181 is not divisible by 8. So we can eliminate them. We're almost there to the end. 9. The sum of the digits must be divisible by 9. The sum of the digits is 10, so it's not divisible by 9. Definitely not divisible by 10 because the number doesn't end in 0. And 11, well, now this is the tricky one. This is the tricky one that I actually made a whole new separate video about. And this video, in that video, I said and I explained that the sum of the alternating digits, so in this case, 1 and 1 are one set of digits, and 8 is the other alternative set. Well, if you subtract these two terms, the result must be 0, or it must be divisible by 11. But we know for sure that 8 minus 1 plus 1, which is 6, well, we know that that's not divisible by 11. So we're going to eliminate 11. Wait, we just eliminated all of these. And by doing this, we can formulate that 181 is probably not going to be a composite number, right? Because we just went through the basic numbers, and when we went through these basic numbers, well, we just figured out that 181 is not divisible by these basic numbers down here. So by doing this, we automatically know that 181 is probably going to be a prime number. You might think, what about numbers like 13 or 17 or 19? These numbers we haven't learned divisibility rules for. Remember that numbers that are large, like in this case, Usually these numbers are not going to go in small numbers like this 3-digit number. Make sure to check these for 4-digit numbers. Usually for 3-digit numbers, this is not the case. So I do recommend you checking up to probably number 13 if you really want to make sure this is not a prime number. But starting from above 19, I recommend you not to waste your time to check those and just put prime, because usually those numbers will divide into this. So through this, we can conclude that 181 is a prime number. Now let's look at one more example. Let's look at example B. Is 68 a prime number? Alright, let's see if this number is a prime number. And we start, of course, with the process of elimination. So we start from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And especially for these 2-digit numbers, you don't really have to go beyond 11. So let's start. Does 2 divide into 68? Definitely. So we automatically know now that this is a composite number. So let's circle this. And the reason I'm doing this is because, one, I wanted to show you guys that you don't have to go beyond 11 for most of the times. And number 2, I wanted to incorporate divisibility rules one more time with an easier number so that you can basically have that concept fixed into your brain. Let's look at 3. So let's remember the divisibility rule for number 3. Alright, what was the divisibility rule for number 3? That was the sum of its digits must be divisible by 3. Well, is 6 plus 8, which is 14, divisible by 3? Nope, so we can eliminate this. Let's go to 4. The number formed by the last 2 digits must be divisible by 4. Well, we can immediately do some mental process. We can do some quick eyeballing here. And we can figure out that 4 does go into 68 because 4 times 17 will give you 68. Let's look at 5. That number doesn't end in 5 or 0, so we can eliminate 5 and 10 at the same time. Let's look at 6. Definitely not 6. 7. We don't see any factors that can go into that. So we can eliminate 7. 8. Nope, because 8 times 8 equals 64, and the next multiple would be 72. So you can eliminate this. Not 9 either, and definitely not 11, because the multiple of 11 that comes before is 66, and the next would be 77. So therefore, we just found evidence that this is not a prime number with these 2 factors. So we can definitely say no, and further we can say this is a composite number. Always use divisibility rules if you can when solving these problems, especially for larger numbers, because you definitely wouldn't have enough time to go in and divide all these numbers into that 4, 5, or 6, even 7-digit numbers.
Math Genie.